Welcome, everybody. Thanks for joining Retrofit Canada and SAIT for Deep Retrofit Discovery Session focused on the city of Calgary. A quick heads up, you've already heard it, but the session is being recorded so that this can be posted later on retrofitcanada.com and its social media channels. We want to take a moment to show our gratitude, respect to First Nations who have inhabited and cared for these lands long before today. We're grateful for their millennia of stewardship that has taken care of trees to give shade, water and food to sustain us, and paths to connect us. We recognize the unceded and traditional territories of many First Nations where we now live and work. This is the first in a series of webinars all about the importance and benefits of deep energy retrofits on residential buildings. And we have some great panelists here today to tell us more about that. I'm Andy Coburn. I'm very happy to be your host today. I'm filling in for Retrofit Canada's Executive Director, Tim Wilson. And today you're going to hear from three experts in the field, starting with architectural and building science technologist Ben Hildebrandt. Ben is the principal investigator with the Green Building Technologies Division at SAIT, and he brings years of experience as a building envelope expert and consultant. Our next presenter is Peter Darlington of Solar Homes Incorporated. Peter is recognized as a leader nationally and in Calgary for single detached net zero and net zero ready retrofits. His work also includes helping to shape industry standards, promoting smarter and more sustainable building methods. And we'll hear from Steve Norris, founder of Snap Building. Steve is a sustainability-focused consultant, developer, and contractor in the Calgary area, and an expert in high-performance building practices for residential projects. Our experts are going to introduce you to deep energy retrofits and present case studies that describe the actual work of executing this type of renovation. And a bit of housekeeping, we'll take questions after we have heard from today's presenters. So if you have a burning question, feel free to post it in the Q&A section. You can see the Q&A button at the top of your screen. And you can also vote for questions in the Q&A that you want us to tackle first. So please be clear also about who your question is for, and we'll get to them in order. On a special note, we'll tell you more about an opportunity at the end for Calgary-based attendees, more at the end of the session. So let's get started with our first presenter, Mr. Ben Hildebrandt. He's up first. Ben, I'll turn this over to you.
All right. Thanks, Andy. Really appreciate everyone joining for the call today. I just want to speak for a quick minute about Retrofit Canada. I'm one of the members of the board of directors at Retrofit Canada, as well as my role at SAIT. Retrofit Canada was founded just a couple years ago with assistance from the Sundance Housing Co-op, Natural Resources Canada, and SSRA, or the Smart Sustainable Resilient Infrastructure Association in Alberta here. Retrofit Canada is an open source deep retrofit organization. We're really focused on sharing information around retrofits through venues such as this webinar, and also through case studies on the Retrofit Canada website. And the goal is to start a movement on how everybody throughout the country can be making their existing homes and equipping contractors to have the tools and knowledge to make existing homes take them to net zero level of performance. I'm going to spend a couple minutes just kind of going through a deep retrofits 101 for those who may be a bit newer to the concept. So I'm just going to cover some really high level aspects of that. And there we go. I've got my screen sharing bar in the way at the top for some reason. Got that out of the way though. One of the main reasons we look at buildings is further and improving buildings is further impact on Canada's greenhouse gas emissions. So we look at building operations and materials that go into new construction and renovations in buildings. It accounts for about 30% of the overall greenhouse gas emissions in Canada. And we look at the 10 million or so homes that exist in Canada. It's greater than 10 million homes. It's just a nice round number to show for a presentation. They're in a situation where they need to receive deep energy retrofits before 2050 to achieve the net zero levels of energy performance and to achieve the building aspect of net zero emissions for 2050, part of the federal climate goals. So how do we do that? And just to give a bit more of a concrete number in that. If we look across Canada based on housing completions, and this is data from Statistics Canada, there are over 4 million homes completed between 1955 and 1990. Or say these are units within homes, so some are combined homes or whatever. But there's over 4 million of these that were completed between 1955 and 1990. That doesn't include all those that were completed before or since, but this is just one snapshot of all the homes in Canada that the majority of them are in a condition right now where they're primed to have these deep energy improvements completed on them. So it's important to kind of see what we can do and help equip the industry to be able to move forward. When we look at improved energy performance on existing homes, it's important to look at where that energy is going to begin with. And in Alberta, based on 2020 numbers, we're using almost 66% of a home's energy on space heating. So that's the key aspect we look at in reducing the energy performance through several methods. When we look at what a deep energy retrofit is, it's important to kind of look at that overarching definition as well. We're not just looking at reducing that energy use to reduce emissions, but what's the goal of that? And the main thing we look at for deep energy retrofit is when we're doing a series of changes to a building that's lowering the energy needs of the building so that the remainder of those needs can be provided by emissions neutral sources. When possible, we want that to be on site to be able to achieve that net zero energy performance label, primarily through CHBA right now in Canada for these homes. But it's important to kind of look at that overarching definition. When we look at like a specific percentage of savings, there's a couple definitions around there, but federally, generally, it's 50% improvement in energy use as well. But the goal overall is to be able to get to that point where we can achieve a net zero level performance through using renewables and other emissions neutral sources for our energy in our homes. What kind of changes are done through a deep energy retrofit? Primarily, we look first at the envelope improvements. We look at improving the air tightness, upgrading and adding insulation in the building, and adding high performance windows and doors. So we're minimizing that heat loss in the wintertime. We're minimizing that heat gain in the summertime to provide a more comfortable home that requires a lot less energy to condition. Once we've tackled that aspect of things, we look at electrification. So electrification is removing any needs for natural gas within the home. So that consists of upgrading the HVAC systems. We have efficient heating, cooling, and ventilation systems that are electrically powered. So we're removing our dependence on natural gas for the home. And that also applies to domestic hot water and appliances as well. And then once we've upgraded the envelope and we've electrified all the uses within the building, that's when we add the cherry on top of that renewable on-site energy generation, primarily through solar panels on the roof. The result that we get out of these steps is net zero performance. So being able to produce as much energy as is consumed over the course of a year. And when we are able to do that, it's great. An important thing to look at too is minimizing those loads. That's where the envelope improvement up front comes in. And that allows us to reduce the loads on the home before we electrify. And as we electrify our homes that have had the improved performance, that's going to minimize the impact on the grid. That's one of the huge concerns that many people are talking about through electrification. Are the electrical grids going to handle it? Key aspect of that is reducing the loads in the first place before we electrify. And there's a lot of benefits to deep energy retrofits. A couple of the key ones we look at is the improved occupant health and improved thermal comfort we get in the home. It's a lot more than just the energy savings and reduced emissions that are the general conversation. But here's the day-to-day impact that everyone in these homes can feel. One of the key aspects of that improved health is through the utilization of heat recovery ventilators in the retrofitted homes to be able to provide continuous fresh air despite outdoor conditions. So we have fresh air running all the time that's well filtered. Works great. Other benefits that we have through deep energy retrofits is noise reduction primarily through the air tightness and improved thermal insulation around the building. You're hearing less noise from outside, and this is a key advantage for homes that are right next to to primary roads in cities. We also have an extended life of the building and increased resale value. When we look at one of these retrofitted projects that have had the whole renewal of the building, new insulation added on the outside, new cladding, whole new mechanical system, we've renewed the building, as it were. Pretty much every single component within that home that is going to age out, need to be replaced, does get replaced during the course of retrofit. So you have a brand new home essentially. And that directly impacts the resale value as well, just from the renewal of materials, as well as the increased efficiency of the home also has an impact on the improving the resale value of these homes. The main obstacle we look at with deep energy retrofits, which can be phrased as an obstacle, maybe it's more of a consideration, is to look at the cost. There's several aspects of cost we look at as an obstacle. The key thing is the high upfront cost to have these projects done, especially if you want to do all the work at once. It's very significant and out of the reach of many Canadians. The other thing we need to look at with cost is to consider the maintenance that's needed anyways, separate from efficiency improvements. If we need to replace our cladding system and our windows and doors anyways to tackle energy efficiency improvements through added insulation and using higher performance windows, is only a marginal increased cost in comparison. The other aspect we look at with cost is recognizing the total cost of ownership. We look at not just the upfront cost, but how's that going to impact on utility savings annually moving forward? How is that going to impact on maintenance of the home moving forward, particularly if you prioritize using low maintenance materials in a retrofit? So there's a lot of considerations we look at for how to gain a better perspective of the high cost impact of a retrofit, and to make that case to homeowners and many of us to our wives as well in how we can get these projects to move forward and make sense for everyone in the long term and for our pocketbooks. One consideration we need to make sure we do with deep energy retrofits is to avoid what many of us have become to call piecemeal retrofits. So doing a little bit of energy efficiency improvement over here and a little bit of improvement over there, here and there without an overarching plan. One of the key risks of that is locking in inefficiencies that you can never get past or are going to be more costly to correct with an overarching, properly planned retrofit moving forward. One key example is this home in the picture, which has undergone a deep energy retrofit now, but just 2 years before the deep energy retrofit was undertaken, they had solar panels installed on the roof and all new shingles on the roof. But as part of the panelized retrofit that this home received, they had to entirely take off that roof system, take off that solar, put on a new roof and new and additional solar panels. But that 2 year prior work was kind of wasted to an extent as well. So we can avoid these haphazard piecemeal retrofits through proper planning and recognizing what we need to do. When we plan for deep energy retrofit, we look at starting off with a building evaluation and energy model and dialing in what the best 2050 net zero version of that home is, and then look at how we want to get there. At SAIT, we work closely with Retrofit Canada to kind of develop this roadmap graphic, kind of identifying here's the key steps through a retrofit project, from the initial assessment through planning and then through the actual implementation and completion of that retrofit to make sure we're completing the key steps and nothing's missed, and overall to ensure the success of that retrofit so it performs properly and the homeowners are happy at the end of it with the outcome. There are lots of options that we look at with a deep energy retrofit. What type of exterior wall insulation are we going to do? What's the foundation insulation strategy? What are we going to do for roof insulation or air tightness? What are the mechanicals going to look like? How's that electrical impact going to be when we electrify? Are we going to have to upsize the panel? Are we going to do retrofit all at once, or are we going to have to do planned phasing or staging it over multiple years? And how do you minimize the rework needed when you do the windows 1 year potentially and the siding a few years later? How's that going to work? Proper planning and design is one of the key things that's essential to determining what the optimal methods are for completing these retrofit projects. And there's a lot of things that go into it, and we're working really hard, both Retrofit Canada and SAIT right now, to provide information to help support the successful planning and execution of retrofits across the country. Both SAIT and Retrofit Canada have received funding from Natural Resources Canada under a couple different programs. Some of the things we have going on right now with Retrofit Canada is the enhancement of the existing case study library on Retrofit Canada to make it an in-depth repository that's easily accessible of retrofit information, and then also webinars such as this to kind of share basic information about retrofits and feature actual retrofit projects such as those that Peter and Steve are going to be sharing shortly from cities across Canada. And SAIT right now, we're in depth working on an extensive training program for contractors that will be planning and overseeing and executing retrofit projects. We're right in the middle of developing the content for that right now. We'll be piloting it this coming spring, and we'll have a full launch of the program this coming fall, not just at SAIT, but we're partnering with other schools across the country to help roll out this program to provide training that we see as very needed in the industry to help equip everyone to complete successful retrofits. So that's my whirlwind introduction to Deep Energy Retrofits. If you have any questions about this, drop them in the Q&A. We'll be more than happy to address them at the end of after Peter and Steve talk. Thank you.
That's excellent. Thanks very much, Ben. A really great capture of what goes into the planning process, structural process of a deep energy retrofit. So let's dive in with our second presenter, Peter Darlington. He's going to bring us some real world projects. And Peter, please take it away.
Great. You should have my slide deck up on your screen there.
Yes, sir.
Good afternoon, and thank you Retrofit Canada and SAIT for organizing this. My name is Peter Darlington. I operate Solar Homes Inc., and this is my home. It was renovated in spring 2015. It's warm, it's quiet, it doesn't have any smells. Its operational energy costs are zero for the home and one car. The main components that make for a successful net zero retrofit have been used individually for many years. Air tightness, insulation, fresh air delivery, and electric heating systems are not radical tech. The idea of putting all these components together and thinking of the house as a system is where things get a little more complicated, but the general ideas are still relatively simple. What's complicated is how we tie all the individual components together to achieve the desired result. In this presentation, I'll try to address some of the challenges we have faced and the solutions we have developed over the past decade. What you'll find is that every home and homeowner is different. Some will have the budget to do it all at once, which is ideal, while others will phase over several years as budget allows. Each home will have its own unique challenges. One of the biggest challenges I've faced in 25 years of running an exterior cladding company is subpar work by tailgate contractors. This is why I joined the Canadian Home Builders Association and got involved at the national level to help design and implement a national labeling program. Who better than the Canadian Home Builders Association to design a high-performance Canadian net zero label? Things I particularly like about this labeling program are that to get a CHBA label, the renovation must be performed by a CHBA builder or renovator and energy auditor who've been vetted for insurance, warranties, training, and quality of work. All CHBA labeled homes must meet a series of required measurable deliverables, including a building envelope that is 33% better than a new code-built home. Being under 1.5 air changes per hour, indoor air quality checklists, and having the ability to generate your own energy on site. As Ben mentioned, about almost 70% of the energy an existing home uses is for heating purposes. If you wanted to generate all that energy through solar PV, it would require several times the amount of space available on an average lot. We start with a baseline of the existing property, produce an energy model, which also includes solar PV potential. Then we can modify individual components of the home's envelope and mechanicals to get the energy numbers to match the solar potential of the existing property. Making energy consumed equal energy generated on an annual basis is one of the main requirements of CHBA Net Zero Home. Most of the homes we work on are 2x4 construction with an effective R value of about 8 or 10. We typically add 6 or 9 inches of outbound insulation, bringing the effective R value to R30 to R40. There are many ways to add R20 or more to an existing building, but what I find especially challenging is air tightness. There are so many transitions and places for air to get in under pressurized conditions. A complete and thorough air barrier is required to cover not just the field, but all material transition locations and where all mechanical penetrations exit the building. Particularly challenging is the attic. Every attic is different, and you don't really know what you're dealing with until you've sucked all the old material out. Air leakage locations include top of walls where trades have poked holes to carry wires and lighting, combustion chases, and vapor barriers that basically serve no function at all. We've tried several different methods, including caulk and spray foam cans to detail all the trouble areas, spray foaming the entire area, which is pricey, and we had one project where the existing poly was actually in good enough shape that we were able to use high performance tapes at all the seams and wrapped air barrier from top of wall up and over the top of wall plate. Most of the envelope transitions, such as windows, window to wall, concrete to lumber, and exterior penetrations, can be solved with high-performance tapes or liquid-applied barriers. Typically, a 100 amp service is available on most homes. Switching heating systems over to electricity from methane or natural gas adds a significant amount of load to an existing service. In some spots, a service upgrade is possible and simple. In other buildings, some type of load share may need to be used. There has been some new items come to market on the load share side in the last couple of years that make this a little bit easier, but you definitely want to have an electrical plan going in. A very efficient way to reduce below-grade heat loss is to hydrovac the perimeter of the home to footings and drop a 4-inch XPS into the hole. This gives an effective R20 on the exterior of the basement. Often this goes smoothly like the photo on the right, but once in a while it does not. The photo on the left is where we had sand backfill, which collapsed as we were going. You can also find some pretty big rocks and concrete chunks and all kinds of things that they threw in the hole before backfilling. And a lot of those spots you just have to cut around with it and live with it. Again, it's one of those spots where you don't know what you're going to find until you start opening it up. There are many reasons a homeowner may want to phase the project over a year. No, it's always money. These renovations are expensive and a considerable investment in one's home and health. Phasing projects over a number of years is common. Typically, the first phase is always envelope, as the level of envelope performance will dictate all decisions further down the road, heating, electrical. A poor envelope, such as just adding an inch of insulation under a reside, can basically permanently kill a path to net zero. We have done many building envelope upgrades where the homeowners come back to us later to complete the mechanical portion of the renovation when their finances allow. You know, it's a pretty good business model because these people just keep coming back to you a couple of years later for a bunch more work. This home on the photo was an emergency roof replacement where we added 10 inches of EPS above his existing roof structure and then a steel snap block roof. This one was a pretty cool job. It was inside of the 4-foot setback. And to the city, we argued that the level of life safety and building performance is not decreased. So we wrapped this building in a full fire blanket brace, basically 6 inches of rock salt insulation and steel cladding. So in order to put about 8 inches of non-combustible wall with windows, it's the windows that's the big problem inside of the setback. Each jurisdiction has the ability to make their own decisions, so nothing is guaranteed, but this was a good win. Since the EnerGuide rating on this home, they've added heat pump heating, bought an EV, disconnected their gas, and are adding solar this spring to cover the energy requirements. This is the second home we labeled under the CHBA rental program. It's thought that you need nice south exposure for solar. I would suggest that's not true at all. In my opinion, an ideal candidate for a net zero reno has a north-south roof peak, which allows you to use both the east and west sides of the roof for generation. The reduction in annual generation, but by being east-west, is more than made up for with the fact that you can use both sides of the roof. Park City Home number 2, they kept their existing windows, but did a 6-inch EFIS with centrally ducted heat pump. Their electrical service upgrade was cost prohibitive, and since they did not plan on disconnecting their natural gas, think barbecue, they chose to pair the heat pump with gas backup. This particular home attempted to save cost by buying a DIY heat pump online, which ended up costing them as much as a brand new Daikin would have. I absolutely do not recommend this. It will be very difficult for them to get this heat pump serviced locally. Solar has since been installed and their EnerGuide is 0. This home in Palacewood went with all new Inotech windows, 6-inch Roxol and Hardie siding. They have a Coben load management center, which avoided a service upgrade. Heat pumps and an ERV. I suspect the solar will happen in the next year or so. I'm going to do a couple slides on a chainsaw retrofit. This was a different option. The heel height on this home was particularly challenging with only about 2 inches between top of wall plate and underside of sheathing. Once you added attic ventilation, there was only 1 inch for insulation and airtight measures. Decision was made to do a chainsaw retrofit, which involves cutting off all the overhangs, wrapping new air barrier and insulation on top of the existing roof, and then framing new overhangs. We were able to do an airtight barrier and 18 inches of insulation to the roof assembly. We went from a Dutch style truss assembly to a more conventional gable roof, which added significant solar potential. The homeowner chose a steel snap block roof. This home also added 6-inch Roxol with Hardie siding, replaced all the windows with Lux triples, upgraded their electrical service, disconnected their gas, ducted heat pump, and solar PV. So I mentioned there's various ways to add R20 to an existing building. We started 10 years ago with EIFS, which is an excellent solution. However, woodpeckers have become more of a problem recently. We then went to Roxol with Hardie siding, which again works well, but has its own unique challenges. Roxol is a compressible material, which requires strapping and long mechanical screws that have to catch existing studs, which can be really frustrating. Also, material supply has been challenging, so we started using a modified Larson truss assembly, which incorporates a structural box beam made out of 2x8 at the base and 2x4s attached to existing truss ends. This is then filled with dense packed cellulose. This particular assembly is easy to build, has materials which are very easy to source, has very limited thermal bridging, and has carbon sequestration potential. Framing a wall outside of the existing wall also allows us to create a perfectly straight facade. And in some spots, we don't even have to remove the existing cladding on these buildings. Our mission is to provide homeowners with a warm, comfortable home, which has the best interior air quality possible, 0 operating emissions, and 0 operating energy costs. Our process has gotten more and more efficient over the years and is getting close to being highly scalable. There are, as Ben mentioned, millions of homes in Canada which will require retrofits over the coming years, and we're very proud of the work we've done to help build the industry. Our homes represent hundreds of tons of emissions reductions annually and thousands of tons of lifetime reductions. I think as these renovations become more mainstream and building codes evolve, it will be silly to consider any lipstick upgrade without considering the opportunity to significantly lower energy requirements and improve occupant comfort. Saw a few different houses there with varying levels of energy improvement. I think what's interesting is that while all the paths are different, they mostly all end at a net zero home. We absolutely love our home. One of the initial goals was to prove that emissions reductions could be achieved without lifestyle compromise. And in fact, the opposite is true. The HRV or lungs of the home do an incredible job bringing in fresh air. We have stable indoor temperature conditions. We never smell smoke. There's no bugs, and we have very little dust. At the end of the day, I think it comes down to a choice. Would you rather spend the rest of your life paying $300 or $400 a month to energy companies to generate your energy off-site, or rather use that $300 or $400 a month paying down assets on your property, which make you comfortable and generate your own clean energy? Thanks for your time, and Steve, I'll hand it over to you.
All right. Thanks, Peter. Do my screen share here. Everybody see that okay? All right, how's that?
All right. Well, welcome everybody. I noticed we'll recognize a lot of names in the attendees, so thanks for joining, and apologies if you've seen this presentation before. My name's Steve Norris. I work with Snap Building. Also work closely with Corey McDermott from Beacon High Performance Homes, and we've been doing these retrofits for a couple of years now, and each one is a little bit different. But the one I'm going to present today was originally part of an SSRIA innovation pilot project that we did with 2 other retrofits, and Peter was involved in that project as well too. The one today is also one of our first ones, so you get to see some of the mistakes and learnings that we had along the way too. I picked this one as well because it's a one-shot, all-electric, net zero retrofit done in one, not phased, as Peter was saying. So it is very efficient to do all those things in one phase. I'm also the homeowner, so I'm intimately familiar with what went on in the project. I do have a lot of slides, so I'm going to move pretty quick. So make sure you take note of any questions that you want to ask afterwards. So our home is a 1955 bungalow. It had a total modeled energy consumption originally of about 152 gigajoules a year, which was almost bang on to what my actual utility bills showed that I'd been tracking over a few years. So the HOT 2000 modeling was actually very close to actuals. Because we were doing a net zero, full electric, summertime retrofit, we were able to remove all the gas appliance related venting and our bath fan venting all at one time from the roof. So the only thing that remains now is a kitchen fan vent and attic venting. One of my personal preferences for the project was try to minimize the use of spray foam and polystyrene, poly-based insulation materials. So as Peter was saying, the biggest challenge in a lot of these is air sealing, particularly in the attic. I did choose the manual route, so I crawled around the attic for a few days using caulking and little spray foam can, poly and Acoustiseal for some of the bath fans we removed, which isn't a perfect system, and I kind of limited the amount of airtightness improvement that we were going to have. Although at the end of the day, we took the air changes down from 5.7 to about 2.0. The most difficult part in these is the attic to wall air barrier connection. So I did compromise on my wanting to eliminate spray foam. We used it at the top of the wall to make our ceiling and wall air barrier for continuity and to maximize the amount of insulation that we could get in that limited heel height. So we did need to add low roof venting instead of maintaining the soffit ventilation clearance. We sucked out all the original insulation, which was wood chip and a little bit of fiberglass, and added in 17 inches of R60 loose fill cellulose. One of the learnings from here is that you got to remember to do any electrical lighting modifications that you want, because you're not going to get access to a lot of that after the fact. Otherwise, you're swimming through a lot of insulation. So for the exterior demo, the original home had vinyl siding. It had 1 inch of XPS foam over some of that siding and stucco. It had stucco above, lap siding below, and we started with a partial demolition, but we ended up removing it all so we could get down to a clean slate. And now this is what we do on all of our projects. It's really nice to get down to the original sheeting layer, see if there's any damage, replace any sheeting that needs it, and start from a clean, flat surface. We removed all of our gas-fired appliances at one time, which was great. Our furnace, hot water tank, range, fireplace, dryer, and all the ventilation associated with these appliances, which helps your air tightness. It does really clean up the rim joist perimeter that you want to get insulated from the exterior. You can see in the bottom right, that's where a lot of things tend to come out of the home, a lot of vents and water lines and things like that. And now we're able to insulate that floor assembly from the exterior. So now we have an air source heat pump hot water tank, heat pump dryer, an induction range, and an electric fireplace. You can see in the top left, we were also part of a Passive House Alberta study that involved capping our plumbing vent stack with an air admittance valve under our ceiling. So within our air barrier and thermal envelope, which has been working fine. So we swapped out our natural gas furnace for a fan coil, which looks similar, but just has a backup electric element instead of gas burners. One of the learnings was that we didn't do a proper F280 heat load calculation when we did the retrofit. So we ended up under capacity with the first air pump that we had installed. So we did have to upsize it after the fact. A lot of people ask about ERV or HRV. I chose to use an ERV because I don't believe that we needed dehumidification in the home. There was enough area and we only have 3 occupants in the house. If it was a smaller space, tighter home, more occupants, dogs, there's greater risk of increased humidification in the home. But in this case, we actually want to keep as much humidity as possible to keep it up. One of the biggest challenges often in these projects is ducting to the bathrooms. In our case, it involves cutting open a number of walls and adding some bulkheads. So in some retrofits, depending on client choices, we do leave existing bath fans, but we do remove them and connect them to the ERVs whenever possible. In our home, we have a legal basement suite, a garage studio that includes a ceramic kiln, and NMAX had room on the transformer. So we did do the upgrade to the 200 amp service. And because we had to pull the service off the house anyways, we moved it to the garage and trenched underground to the house. So currently we have a 200 amp panel in the garage, which comes underground to a 200 amp panel in the house. One of the coolest areas of our home was an addition that had been put on in the 1980s. Especially the floor was very cold. It had R40 batt in it, but it was unsealed and had exposed joists, which is a big thermal bridge. Unfortunately, it's a pretty tight space to work in, which wasn't super fun. But we managed to clean out the mouse droppings and the wasp nests, air seal it with Typar, and actually do some additional insulation under the heat runs that were coming out through the basement foundation. We added an insulated skirt, so it becomes in some ways a bit of a semi-conditioned space. You can see in the top left here, Corey building our window boxes. We did a mid-wall install with no flanges, and then we sealed with backer rod and caulking. On the right side, you can see our bay window before and after. We actually took out the bay window and reframed that whole wall with a wider view. It's amazing, a lot of these older homes have super inefficient bay windows that are uncomfortable and cold and very difficult to deal with, but people want to get the same view of the outside. So this was our solution in this case. So ours was the third project in the retrofit pilot, which used 3 different exterior wall and insulation assemblies. The other projects used EFIS and XPS foam. But in this case, our goal was to come up with an insulated wall system with standard materials and fasteners, no foam, and one that was easy to modify according to site conditions. So similar to what Peter's doing now, we started with a Larson type wall. In our case, we were building with 2x2 plywood gussets, which then gets meshed in and filled with dense packed cellulose. We're doing this assembly a little bit different now. We've made some incremental improvements, but very similar to what you see here. So in order to get a continuous exterior air weather barrier, we've caulked our Typar to the plywood at the top and the bottom and fully taped the assembly. Very recently, we started doing a double breathable air barrier. So we've actually been doing our first plane at the sheeting layer. Because we're using vertical corrugated metal cladding, we've strapped vertically first and then horizontal in this case. So we have a nice drainage plane and we use short screws that don't penetrate that air weather barrier. Here's a couple photos of that vertical siding. In the top left, on the right-hand side of the home, you can see where we modified the depth of that wall assembly because we had a basement suite entry. So that's one of the beauties of the Larson assembly is you can change thicknesses on it quite easily. On the right-hand side, you can see I had originally tried to keep 2 original good quality dual glaze windows, but they condensed right away when all those new windows went in and we were able to keep our humidity higher. So we made a very late window swap. Our garage was in the scope of the project also. So we framed down our original double garage door to a single, added air weather barrier on the outside with 2 inches of mineral fiber and a mini split heat pump. And now that functions as a working art studio. So we've been doing a bunch of monitoring on the project for information and research. I'll go through that quickly. I have two air things monitors. We're watching radon, CO2, and particulate when it gets smoky in the summer. We've been monitoring all of our circuits with two Emporia energy monitors, one on each panel, one in the garage, one in the house. We do have 11 southeast panels on the garage, 13 panels on the southeast face of the house, and 15 on the southwest face of the house. Utilities, on the top left, you can see where we removed our gas meter, which was a happy day. We are with the Solar Club utility, which means that we overgenerate in the summer at 30 cents a kilowatt. And in the winter, when we're purchasing more power than we're making, we're paying about 13 cents a kilowatt for that. And we are roughly net zero. So here's the final result. We reduced our 152 gigajoule load down to 51 gigajoules, about a third, and we have enough PV for our 0 gigajoule label. We've been on the Eco Solar Tour for 2 years, and it's been really nice to kind of leverage those improvements for education and business development. So thank you very much for allowing me to present, and I will pass it back over.
Great. Thank you very much, Steve. Very, very interesting projects, and we've got questions aplenty in the Q&A. If you have a question, just a reminder, please do log it in the Q&A, and I'll start right into them. I think this question is going to be aimed mainly at Ben, but if Steve and Peter, if you have an opinion on it as well, please chime in. Is electrification a necessary part of deep energy retrofits? Could you go with mechanicals that such as hybrids or a gas furnace, a three-season air source heat pump? Is electrification necessary?
Technically, no. One of the key aspects we want to do with a deep energy retrofit, though, is reduce emissions. And in many cases, with that goal, we want to electrify where possible. Another consideration to look at in that as well is what's the carbon intensity of your electrical grid. So it's all part of the conversation. I think largely it's part of the homeowner priorities. But federally and officially, I don't think there's any definitions of a deep energy retrofit that require electrification.
Okay. Next question, and it's a bit more broad. It appears Retrofit Canada is aligning, and also the projects that Peter and Steve are doing, aligning pretty closely with net zero energy. How about Passive House? Are you guys shooting for that target as well?
You know, nobody wants to try to compare one labeling program versus another. But I think what's good about the CHBA labeling program is that there's been a couple thousand houses go through it, and Passive House really relies on a heavily insulated building, whereas CHBA recognizes mechanical advantage. In a lot of spots, it doesn't make sense to spend $10,000 on air tightness when we're talking about one solar panel's equivalent worth of energy. So I think that there is a fine line between the two. Passive House is awesome. Their buildings are awesome. But it is a bit more carbon intensive from an embodied perspective, and it's harder to pull off.
Yeah. I think to Peter's last point, I'd echo the practicality of it. And I do like Passive House, they do have the energy sprong system kind of recognizing retrofits and slightly reduced requirements, kind of recognizing you can't really insulate under a slab or even over a slab practically in a basement for an existing home. So Energy Sprong has a bit relaxed standards or requirements to get their certification, but it really comes down to the functional practicality and also the budget to achieve those numbers. And I would say too that some of these projects that Steve and Peter have worked on from an envelope performance point of view, they're probably not too notably far from Passive House. And sometimes what we see even in new construction homes that are Passive House inspired, they come pretty darn close, but sometimes getting over that finish line, especially, and Steve could talk our ear off and Peter as well about kind of the air tightness challenges. of retrofits, and the higher tightness numbers from the pass-fail certifications are often an obstacle in these projects.
Okay, and Steve, let's fire a question your way that's somewhat related to this question. Can you share with us more about the issues with the F280 calculation that ended up causing some kind of a wrong sizing for you?
Yeah, F280 basically is a more accurate calculation of how much heat you need in your peak heating seasons, and room by room as well too. So in certain parts of the house, you need more heating load than others, which is very difficult to dial in a retrofit scenario, especially if you're using existing ductwork. Like if you have a finished basement and you have all this ductwork in that ceiling, you're kind of dealing with oversized ducting for the type of heat that you're providing. Air source heat pump heating is very low grade. It's slow and steady. It doesn't fire up and crank like a natural gas furnace does. So it's important to get the sizing of the heat pump right. F280 is not, in a lot of cases, not an inexpensive calculation to be done. So it costs a little bit. So some homeowners are a little reluctant to pay for that. But in this case, it did. We had a heat load that was on the cusp between two different heat pump sizes, and we basically underestimated a little bit. So that meant when we were going through our first heating season, when our first really cold snap came through, the heat pump wasn't quite keeping up the way it needed to. So we made a quick change there.
Okay, great. Another question, and this one kind of came up in the conversation. It's aiming at Peter, but Ben and Steve, chime in if you have an opinion on it as well. How are materials doing for embodied carbon in your projects? Is that becoming something more prevalent in the work that you're doing?
You know, it's really pretty remarkable, the advances in the last 5 years. There's a lot of talk on embodied carbon. A lot of manufacturers are recognizing that this is something that their customers are looking for. Certainly the spray foams are way down in their greenhouse gas equivalent. And right now we're using all cellulose and wood. So this is really pretty good carbon sequestration. So yes and no.
Yeah, I'd echo what Peter says. There's been a lot of advances on the foam insulation side with low and zero GWP blowing agents being integrated, and also revising some of the other ingredients in the foam insulations. But then there's also been other more natural materials that are getting a larger and larger piece of the pie in the industry, and hopefully, or some that are entering the industry. And I guess a lot of it comes down to what's readily available when we look at these lower GWP products, and also what's practical and cost effective to use. Like we use cellulose insulation for a blown in on a lot of these projects now. That seems to be both an affordable and low GWP option. But then also it's like, what are the barriers to getting like a chop straw blown in insulation, as well? As I get after one producer of chop straw insulated panels for new construction up in the Edmonton area. I was like, let's bring this to a site. But the equipment's a bit large and bit farmish to drive right into the city for all these retrofits.
Right. Okay. Thanks,
You know,
Ben.
what I find interesting, sorry, and just to kind of come back to a question that was asked earlier, was about grid intensity emissions. And in Alberta, we are really, as net zero renovators, kind of spoiled, because when we switch a building over to electric, there's really not a lot of emissions changes. We reduce the amount of energy being consumed, but it's electric, so it's only 30% of the energy out of that gas. So it's about the same. But when we put the solar panels on that buildings, it's a big reduction. It's 10 to 12 tons a year. So when we're talking about a 30-year lifespan of the building, that's 300 tons. And when I'm talking about making a material decision in Alberta between cellulose and rigid insulation. We're talking about a difference of 3 or 4 tons, which is virtually inconsequential to the entire thing. But when you start thinking about nationally, where the grid intensities are much lower, then the embodied carbon involved in putting that assembly together becomes more relevant, a higher percentage of total life cycle emissions. So kind of a roundabout way of answering the question as well.
Yeah, and that kind of brings up, we'll just have one more question. We just got time for one more. Um, when you're completing your projects, that follow-up piece, are you able to monitor? Are you able to collect data after the fact? Is this something that you have, like that relationship with your clientele, that you can do that?
Yeah, I'd say that's a case-by-case basis. Some of our clients choose to have monitors installed, some of them don't. But it's funny, most of, if somebody's coming to us asking for this kind of retrofit, chances are they want to share that with the green building community, and they want their houses to be demonstrations for other people as well too. So when we have asked for that kind of information, people have been more than willing to share, and even to tour people in their homes, during construction and after construction. So it becomes a community thing as well at the end of the day.
How about you, Peter?
Yeah, we're in contact with most of our customers. I like to go by every once in a while and make sure everything's going well. And a lot of them do have energy monitors, and I would suggest it's pretty remarkable how close that Hot 2000 is to their total annual energy consumption. Maybe each line item's not quite correct. Maybe the PV doesn't generate quite as much, or the heating takes a little bit more. But generally, almost all our homeowners are, within 10% of that Hot 2000 model without any kind of extreme behaviors. But it's quite impressive how good the energy modeling actually is.
That's excellent. So we'll wrap up the questions for now. I know, Ben, you have some information about an event that's coming up for some of the attendees in Calgary area. Is that right?
I'll say really quick, and I do want to address one of the other questions really quickly too, but I'll say in-person project tours coming up next week on Tuesday for those in the Calgary area. For everyone who's registered for this webinar, there'll be an email sent out afterwards with Eventbrite logins. So these are projects, one by Steve and one by Peter Darlington. On Tuesday afternoon, they are separate listings, so sign up for whichever one you are able to attend. And also there is limited space for those tours as well. So sign up quickly. And I just wanted to say there's a question about training at NAIT. Our program will be a combination of online and in person. That's why we're collaborating with a bunch of local schools across the country. And we are still in the process of getting formalized agreements in place with that, but we are looking at being able to get some coverage in central northern Alberta as well as southern BC and currently southern Manitoba, Ontario, and the Maritimes as well, with a few other schools hopefully coming on board. But I would stay tuned to Retrofit Canada's website for announcements around that when it's rolled out, and also SAIT as well. So, and also I don't want to forget, because Andy's not going to say this himself, but thank you to Andy for stepping in and supporting the delivery of this session today. We really appreciate it.
Always happy to help, and it's a real honor and a privilege to be able to have heavyweights from the industry like yourselves, gentlemen, to come in and do a session like this. So Ben Hildebrandt from SAIT, and Peter Darlington at Solar Homes, and Steve Norris with Snap. Thank you very much for coming in and talking to us about this very important subject of deep energy retrofits.
Thank you.
Absolutely.
Thanks, everyone.
For having us.
Thanks for joining in, everyone.